I was on my way to voting
No one's talking, so complete silence. Complete silence, sorry. Okay, all of you, preparation for the test after Thanksgiving, so you must make sure you have the limit flashcard memorized. Okay? When they ask you to find a limit, if you follow the limit flashcard, it will lead you to the correct answer about 99% of the time. So when I look at this, I remember this flashcard. And I couldn't quite fit everything on one card, so I made two. I first check to see is the limit of x approaching infinity. If yes, I'm going to compare terms that add to identify dominant terms so I can create a new limit problem. If not, which is the case in number 14 that Lauren is asking about, I'm going to look to see if I can factor and divide if possible. Good chance for some people writing this down, so wait just a minute. That was a bad shot.
That was. I made 2 out of 3.
Be good if it's the NBA, but not so good when it's trash can basketball. Just watching your pencil, I'll wait you to cut up on the notes. Okay, I have a lot of people have trouble with the following, so I'm going to add another flashcard to my deck. I have a lot of people who have trouble with this. These are examples of things I've seen people struggle with. So I believe a flashcard will help. So I would put all of that on one side of my flashcard. I'm just reminding you of things I've seen people have trouble with. Okay, this difference of squares does factor. So x squared subtract a squared will factor into x squared plus x plus a multiplied by x subtracted. Questions there? However, x squared plus a squared does not factor. And it's important to notice that this is always positive. So never 0, never negative. These are really common ways the AP test writers try to fool you into an incorrect answer. Okay, some people think this factors, that's how they trick you. This will also factor. Question? This will also factor. And the last one does not factor. So x squared plus 2 is again always positive. I've seen other kinds of expressions on the AP test, but I don't think I've ever seen anything that doesn't fit one of those patterns. So, we want more discussion, detail, help, a chance to catch up on your cards. back to 14. I'm trying to find this limit. X is not approaching infinity, so I factor first. I create a new limit problem. Okay, again, remember, if you ask me for help and you have no equal sign on your paper and I can't follow your work, I can't help you. Without the equal sign, the grader can give you no points on the written section. You have to say this is equal to this. It just makes no sense otherwise. So I'm saying this limit problem is the same as the next limit problem. More discussion to there. So you can catch up in your notes. The whole goal of factoring is to try and divide. You can't currently divide because none of the numerator factors match the denominator factors. But two ways you could proceed. One, you could say, wait a minute. When this was multiplied together, that was just this. So maybe it's better to just put that back so it will match this factor. So now I have this limit. Question? Okay, when you see this, this is one of those I ask a lot, I'll keep asking it. Because I'm trying to get everyone to the point where on all these basic ideas that just show up again and again and again, you don't really have to think very much. Like you see it, you know it. So hands up, who knows what I'm thinking? What am I thinking as soon as I see this? Let's go, Tori.
That's always be one.
This is always going to be 1. There are a couple of exceptions. If x has a value of a, or x has a value of negative a, this actually becomes undefined. But for any other x, this is 1. You knew it? 1, 2 for Tori. Hands up. Do I worry about the exception in this problem, or do I not worry about the exception? Hands up. What is it?
Don't worry about it.
And why not? Say it again. 2 points. There's a different. It does divide to 1, but there's a specific reason why we don't have to worry about it.
It's when x is approaching a, not when x equals a.
Well done. So I'd have a problem if x ever equaled a, but with the limit x is only getting close to a. We knew it? 2, 3 for Kenny. You want me to talk more? Just go back. Okay. So this is 1. When x gets close to a, this will get close to a squared. So the limit is going to be 1 over 2a squared. Question? Lauren? Cool. Josh, you asked about 16. Say it again for me. Really great. I said his name the same way on the first day too. So. Well, not really, because I knew his brother Joe, but whatever. I think my that's funny. Like when they'll come in the room, I don't like to have to read it because I take out my glasses. I say, just read the name. And then I'll say other things, and they say, they don't even hear a word I say. You're on autopilot. Okay, 16.